Hi everyone. Let's talk about the three-dimensional coordinate system. And in 2D, when we draw the coordinate system, we draw the x-axis like so, and the y-axis like this. And so now what we want to do is to extend this to the third dimension. So you can think of it as the third axis drawn perpendicular to this page through the origin right here. So in this three-dimensional coordinate system that I have on the left, suppose that I'm going to put the positive x-axis in this direction and the positive y over here. Now, depending on how we orient the z-axis, we don't know at this point if we should draw the positive z-axis in the upward direction in this picture or the downward direction. So, the convention that we use, as you read in the book, is what's called the right-hand rule. And I want to show you two different pictures of how the right-hand rule works. So, the picture on the left here is basically telling you, using your right hand, if you were to put your index finger toward the positive x-axis and bend the middle one toward the y-axis, the positive y-axis, then your thumb should point in the positive z-axis. Now, picture on the right is very similar, but this is telling us that we need to put all of the fingers along the direction of the positive x-axis and wrap your fingers around towards the positive y. Then again, your thumb should point in the direction of the positive z-axis. So using that, let's just try this in this coordinate system up here. So if I were to put my index finger toward the direction of positive x and bend your middle finger toward the positive y-axis, then my thumb now is pointing in the direction of the positive z, which is going to be in the upward direction. So this is what I would get according to the right-hand rule. Now, I would like you to try this, but if you were to use the left-hand rule, you're going to get the opposite orientation for the z-axis, and in that case, this would be the positive z-axis. But as you know from your reading of 9.1, right-hand rule is the convention that we go by. So this would be the typical way to draw the three axes. Okay, so now that we know how to draw the three-dimensional coordinate system, let's talk a little bit more about the system here. So suppose that in this picture, what we have is over here is my x-axis, and this is my y-axis, and the vertical axis right here is my z-axis, and you can see that this is in accordance with the right-hand rule. And you can see the three planes drawn in this picture, right? And the one that is horizontal, kind of the yellow color plane in this picture right here, this is the one that is being defined by the x and the y-axis, containing both x and y. So this one is called the xy plane. And the one that is in light brown right here, this contains the y-axis and the z-axis. So this is called the YZ plane. And the one that's in green right here, this is the one that contains the x and the z-axis. So this will be called the XZ plane. Now these three planes are called the coordinate planes. So if you were to ever hear that terminology, I would like you to be able to recognize that. Now I want to make some comparison between the three-dimensional and the two-dimensional space that we were used to. So in 2D, when we draw the X and the Y axis like this, you remember that, of course you can also see this, that these two axes divide the two-dimensional space into 4 separate regions, right? And this over here is called the first quadrant. And this is the second over here, third, and the fourth. I'm sure you remember that. But now in comparison to that, in this three-dimensional space, these 3 coordinate planes divide the three-dimensional space into 8 separate regions. So in this case, each region is called the octant. And the one in particular that we refer to quite a bit is the octant that is being defined by the positive x and the positive y and the positive z. So in this particular picture, we are talking about the upper right and the front octant, and this octant right here, this part right there, is called the first octant. So if you ever hear first octant, I would like you to know that we are talking about that particular octant that is being defined by positive x, y, and z coordinates.